Hi guys, welcome back to my channel. In this video, I'll be taking you through the area of a region between two curves, right? So a region bounded by two curves, and this is an application of integration. Okay, so this is our first tutorial in application of integration. So it says find the area of the region bounded by the graphs of f of x is equal to 2 minus x squared, then g of x is equal to x. Whenever you are given such a problem, the first thing you have to do is to analyze each curve, right? Each curve. So if you have 2 minus x squared, is this is a curve, all right? Yes, it's a curve, but is it an increasing curve or is a decreasing curve, right? So, or is it a maximum? So let me show you here. If I draw this on this, you realize that a curve can either be this way or it can either be this way, right? So in order for us to find a region bounded by this and this, we have to know the one that will be up and the one that will be down, so that we can get our maximum, or we can get our bigger function as in when we are integrating place. So first of all, when we say g of x is equal to x, this is a function of y equals x, as we know, and it's a line that passes through the origin. So that's the first thing you do. So y is equal to what? X. Or you can say g of x is equal to what? X. Then now we come to focus on this. So if I have this function here, okay, if I have this function here, you know that when I take the first derivative, what will I be getting? I'll be getting negative 2x. Is that not it? This will be my first derivative. When I take my second derivative, I'll be getting negative 2. And you know that the second derivative test is used to test for what? For either it's going to be a maximum curve or a minimum, right? So meaning you're going to have a minimum curve, and so far as these two are bounded, meaning that they are touching. But where are they touching? So we're going to have something like this. Okay, but where are they touching? That is where you use the intersection. So you have 2 minus x squared be equal to x because they're intersecting. Okay, you just equate the two, and after you solve simultaneously, you're getting x squared minus x plus x minus 2 is equal to 0. Solving this quadratic gives us x is equal to negative 2 or s is equal to 1. Okay, so what this means is that these two are what? Meeting at points s is equal to what? 1 or negative 2. So meaning that I can plot here to be equal to, I can plot this side to be equal to negative 2, and I can plot this side to be equal to 1. So that is all. So this is a graphical representation, and this is the region you are going to find the area. Okay. So to find the area of this region, what do? We just take a slice of it, a slice of this. So we need our endpoints which we are integrating over. So we are trying to integrate from negative 2 to 1. Okay. So for this integration, or for this integral, we have two functions, which is 2 minus x squared, then we have x, right? So in this part, we have got our limits with which we are integrating over. So from negative 2 to 1, right? Then we realize that our curve 2 minus x squared is what is above, and this is what is below. So we do it accordingly. So it's simply going to be integral, right? Our area is simply going to be integral from negative 2 to 1, okay, of our f of x, which happens to be the one up, minus g of what? X, okay, as simple as that. So gives this becomes integral from negative 2 to 1 of the function f of x, which is 2 minus x squared, minus the function g of x dx. So at this point, what you do is you're gonna have integral negative 2 to 1. Then you simply have 2 minus x squared minus x all dx. So this is a simple and direct integral. So you simply have 2x, right? Here becomes minus x cubed on 3 minus x squared on 2. Then you put in our limit here. So once you do this, you should get 9 out of 2 square units. Okay, you're dealing with area square unit. You can choose not to bring anything depending on the requirements of the question. So thank you so much for being in this video.